Hi, everybody, and welcome to this episode of the Cloud Innovation Podcast. We're super excited to have you wherever you are watching and listening from. In today's episode, we're going to be talking about cloud security. And this is the most vast topic and so many places where somebody can come and attack you, from ransomware or misconfigurations in your cloud, zero-day exploits, open source security, host vulnerabilities, you name it. There just seems to be a never-ending list of places where you can get caught with your pants down and be all over the news. And it's such a vast topic, and we're going to get into it today and hopefully tell you some of the best ways you can avoid the pitfalls of cloud security and spend your money in the best way. Who am I? I'm Nesh. I'm from GlobalDots, and I've been here for about 5.5 years. And primarily my role is in cloud security, FinOps, and web security. And GlobalDots is an organization that's been running for 20 years, looking for new innovative technology from across the world, finding cool new vendors that people didn't hear of, and then bringing them to market. So my job is as a technical sales engineer, finding the new technology and also introducing the new technology. And I'm joined on the show today by my colleague and good friend, Francesco.
To say it with Charles Dickens, hi-lo, this is Francesco Altomare. I've been working with GlobalDots for 10 years now. I joined GlobalDots 10 years ago as a sales engineer. These days, I also run sales operations across Southern Europe. Pleasure to meet you.
Just to mention, if you are watching this on Bright Talk, please be sure to leave any questions you want answered, and we'll get back to them at the end of the stream. Now, let's get into it. I guess let's start with why there are so many places that are now open to attack, and then how we can what's the best way to cover those bases. I guess the biggest problem for us at the moment in the cloud security world is that all clouds look the same. And in the old days, you used to have that different clouds were configured in different ways because they were private clouds, and you had to, there were idiosyncrasies in people's platforms. But now all clouds look the same. All the services are available to all people. And as soon as a person or an actor has got one foot inside your door, your attack surface is absolutely huge. I mean, what do you think about this, Francesco?
That's the case. Clouds can be penetrated from all angles, and there are just countless attack surfaces, so we like to call them, from which a malicious entity might attack you, get access to your premises, and then wreak havoc from the inside out. There really aren't limited attack surfaces here, and if I really have to drop a horror story, who particularly resonates with Italy, it was the ESXi ARX attack that happened 1 month ago. This hit up to 70,000 servers, and the worst of it all is this attack exploited a vulnerability which was well documented in February 2021, and for which a fix was available starting with February 2021. How cool is that?
And I think that kind of hits the nail on the head, that even things that are completely known about get totally missed inside your estate. And from experience of looking at various customers we have and people who come towards us, one of the huge problems is just too many places to look. And I think if you think about, let's say open source vulnerability is slightly different to host vulnerability, which is slightly different to lateral movement, which is slightly different to Kubernetes security, which is slightly different to cloud entitlements and management, and all these things. And until recently, all of these have been covered with a solution for each one. So you suddenly get to the point where even if you've got an advanced security team, you've got like 10 pieces of software to look at, which, it's just too many places to look and too many tools you need to onboard. What do you think about that?
Absolutely, Nesh. I think we're best off possibly exposing some of the most well-known attack surfaces and how you should deal with it. And then ideally also wrap it up with the analysis paralysis scenario you just mentioned by talking about convergence of data.
Sounds like a great plan. I would say should we dive into what Gartner would call them, because I think probably the Gartner seems to rule the world in terms of how people understand things. So in case you're not aware, the most favored way to bundle a number of these different attack vectors into one place is a CNAPP, and that's a cloud native application protection platform, which is a proper mouthful. Francesco, do you want to expand for us? What is a CNAPP?
Very gladly. We love to get buried under acronyms in this industry. And so, of course, CNAPP consists of yet another 3 acronyms. If we look at these from a historical perspective, we're then looking at the CWPP, CSPM, CIEM. Each and every one of these focuses on entirely different things, but I try and keep things simple for you. See the horror story I mentioned before? Well, that's a typical horror story that wouldn't have happened with a CWPP, Cloud Workload Protection. So the CWPP, which is also the oldest brother of M3, right, was born, or at least it was created as an acronym a handful of years ago, I think 5 or 4 years ago, roughly speaking. This product, this category of product has all to do with protecting hosts and from their own vulnerabilities at the hosts level. The ESXi ARX attack exploited a typical ESXi host vulnerability. Products like these deal with these vulnerabilities in that they patch them, right, for you where possible. And if not, at least they expose them to you for you to then go ahead and patch them, especially when you had over 2 years' time to do this. Follows CSPM. This was born around 2020. CSPM, to stick to the cloud, has much more to do with things like security policies, exposed buckets, things like these. Things that don't, strictly speaking, have to do with your hosts, also because some of these things simply aren't IaaS products, if you know what I mean. Some of these are managed to some degree. Nevertheless, you're still the one assigning policies and rights to these products. So if you have a bucket containing sensitive data and this bucket's not supposed to be public, but it is public, a tool like a CSPM tool, Cloud Security Posture Management tool, will tell you about that. And then, of course, it's up to you to make it not public again. Finally, the youngest brother called CIEM. This has instead everything to do with identity. Okay, the assumption being that no attack can happen within your premises without an identity to carry it out, right? Be it a human, be it a system identity, machine to machine. And so, of course, what a CIEM tool does is mapping out the relationship of so-called IAM roles. I'm sticking to AWS terminology this time around, and well, showing you the potential of how far can a given identity, due to its policy, reach out to, especially if malevolent. I'm basically talking about the least privileged access, which we all talk about every day, and we all know it's a nightmare to implement. So CNAPP is basically the sum of them 3 products brought together courtesy of countless companies out there, and we appear to be specialists in this world. Did I sum it up, Nesh?
Yeah, that is actually an excellent summary, and it's funny because the CNAPP, as much as I hate it and as much as I hate the acronyms, it was actually necessary to describe something that encompassed all of the previous acronyms in a tool. And it's a way, if you don't understand what the CNAPP is, it's a way of solving so many problems in one place. That you cover so many more bases that you don't need all of those previous tools we talked about at the beginning, where you have one tool for X, another tool for Y, and another tool for Z. You know, you're bundling as much as you can into this one place. And there's some things are just not exciting anymore. For example, host vulnerabilities, and I can talk of a company maybe like Tenable that people are familiar with, or Scan or something. It's old. Everybody knows about it. It's something you need to deal with. Same with open source security. You know, it's you need to scan your software as you're packaging it out for open source vulnerabilities. There's nothing special about it anymore. Just bundle all that together. And that's what the CNAPPs have essentially done. They've bundled all these nice bits together. The bit I think is really cool is that because they're all in the same place, that you get machine learning to look at the information from all those aspects, and actually you can knit parts of the story together that didn't used to be possible to knit parts of these stories. So let's say, for example, you do get a bad actor inside your cloud estate. Maybe they get an access key, or somehow an employee's laptop is compromised in some way. If they start doing strange things inside the estate that didn't used to happen with that user or from a specific region, you know, that's going to be flagged up. And then if they start creating infrastructure or doing something that is also unusual, that's going to be flagged up. And then if there's a bucket that didn't used to be open to the world is suddenly made open to the world, and then lots of data is coming out of that bucket, you know, it's a way of getting all these different contextual points and tying them together to make a richer narrative. And it wasn't something that was available previously, and it's just pretty cool that it's available now.
Yes. So Nesh, let me see if I got it right. I'm company XYZ. I contact you. I get myself a CNAPP platform. I'm done with cloud security. Did I get you right?
In the land of lollipops and chocolate trees, 100%. Yeah, you're secure. No, we both know no, and you know, we're both talking to we're both talking to CISOs and high level ranking IT security officers, and I think we know the biggest problem they have is that they know they need to buy loads more tools, and they just don't have the money, and everything is a budget. So it's just, what can I get for my money that's going to cover me in the best possible way? And then also knowing that if somebody really wants to get you, if they really want to get after you, you could almost do nothing to stop that unless you are the FBI or the NSA or the MI5 or something like that. You know, you have to be seriously top of the game not to be able to stop if somebody really wants you. But, you know, I would say the CNAPP is the biggest bang for the buck, quick fix. What do you think is next in line?
Well, for one, we didn't even start talking about networks. So why don't we?
Great. Kick us off.
If I may, I'll drop another couple of acronyms, right? So the first one might be ZTNA, and the other one might be SASE, SASE, right? Not SAWSY, which is another thing. So ZTNA, Zero Trust Network Access. We all talked about it. Everyone's heard about it. It's no news by now. Like, the pandemic made it a big thing, and now everyone has it under the skin, right? ZTNA has everything to do with not trusting whomever approaches your network from wherever he comes, whomever he claims to be, and wherever he wants to go, right? ZTNA is more of a philosophy of doing networking than anything else. And then, of course, around this philosophy, a whole industry was born. In fact, we have countless technologies covering this these days. We won't, spend time talking about each and every one of these. I'll just say Zero trust network access is a way of doing network access where you basically don't trust anyone. Think of your employees connecting from remote, smart working, right? And well, even though you know John Smith is John Smith, you won't trust John Smith is John Smith until John Smith can prove he is John Smith. That's it, very basically. You go through a layer of authentication, and then you go through a layer of authorization. And at the authorization stage, it is not a given that John Smith will be able to roam free throughout your infrastructure. Stemming off, ZTNA come SASE and possibly also microsegmentation. Let's start with the microsegmentation one first. John Smith tried to access your network to work his day, and he proved he is John Smith, right? However, John Smith works in engineering, so he needs no access to either payroll or whatever financial data, etc. So what do? You do microsegmentation. Microsegmentation means, thank you, John Smith, for proving that you are John Smith. However, you can only go this way. You cannot look at anything else in our premises. That's it, very basically. It helps you to minimize the damage radius of John Smith going havoc or losing his laptop to some malevolent entity who can then do the so-called lateral movement. Who hasn't heard of lateral movement these days? Finally, let's spend a word on on SASE. So what is SASE? SASE is yet another acronym, which is the sum of things like SD1, RBI, and many, countless actually, more acronyms. SASE is basically a new way of doing networking. I'm talking about east-west networking, as well as north-south networking, whereby the logic of firewalling, IPS, anti-spam, CASB, just to name another one, is shifted from your premises, your good old appliances, right, to the cloud, back in the cloud. So basically, what SASE stands for is keep doing networking, keep doing security. However, there's no point in purchasing Stone Age old appliances who will go end of life at some point, and which you have to be physically present to tune and configure when they need tuning or configuring, but rather shift all this logic to the cloud. Why? Because the cloud is elastic, it's scalable, it can do a better job than your on-prem metal-based appliances. And finally, it allows you to govern it from anywhere in the world. Anywhere you'll be able to run SASE. Yeah. What do you think about it, Nesh?
Yeah, I mean, it was great. You even dropped a few more acronyms, which we didn't unpack. But if we unpack all the acronyms, we'll be here until the sun dies. But yeah, the SASE and the zero trust, they're, to think about zero trust and what the problem it's solving is crazy, because the old VPN style infrastructure, very typical for people to have blanket network access once they've authenticated. So just if you're talking about internal networks, it's like 10.0.0.0/8, and just saying, yeah, if you're on the VPN, you can see everything, which just completely blows your lateral movement, because it means that someone can go everywhere. So the zero trust aspect, makes perfect sense. And the SASE side of the world, and by the way, zero trust is a kind of philosophy, because if you were clever enough to know how to limit access in the old days, people have been doing zero trust since remote access began. They just didn't call it zero trust. They were just high functioning security companies or something like that. They were just more mature. And the SASE thing, it's, we lost the office, the branch office and the headquarter model quite a while ago. And now we have everything in the cloud everywhere, from SaaS platforms, PaaS platforms, and remote working. No vast majority of people working from home and from other strange locations. The idea that you build a network to be able to encompass every person, their working situation, and all the different ways they want to connect into the office is crazy. Nobody should be doing that. It makes perfect sense that there are large cloud providers with an overlay on top of the internet providing, your portion of the private network, like your virtual private part of the network. And this is, the SASE provider and the zero trust, I think we'll definitely see a merge of those technologies in the future. There's no two ways about it that SASE and zero trust are wedded together, and they'll become a one product, of which the maybe there'll be a new acronym, something to look forward to.
Oh, yeah.
Oh yeah, but zero trust, I see an explosion of that in this year alone. It's been there for a few years and people are doing different offerings for it, but I really see in the last 6 months or so the number of people requesting POCs, or the number of people that are interested in looking at that is it's explosive at the moment. So I'm gonna throw the same question back at you then, Francesco. So now we've covered roughly talking about SASEs and what they do, which includes all the remote access and all the nice stuff, and zero trust and roughly what that is. And we have a CNAPP. We're totally covered with security now, right?
Yeah, sure. And that's if you don't run code or APIs or interesting stuff in your premises. Because if you do, we're not done at all here. Maybe we can look at APIs as a vehicle, as a vessel for an attack next. So let's talk about it. API, another acronym. How funny is that? API. Okay, well, these have been around much, much longer than CNAPP, we'll admit. However, what you're also possibly aware of is that they're booming. They've basically been booming for the past two decades, and they'll, in my opinion, keep booming for the next 5. AKA, we're letting machines talk to machines, and much less traffic these days is made by humans against machines than machines with machines. APIs are all about communicating data. It could be sensitive data, it could be sales orders, it could be security information, it could be all kinds of things. Fact is, APIs walk amongst us, and these can be hacked into. And if an API endpoint protects sensitive information, such as personally identifiable data, then you don't want to be there, right? API traffic and attack tactics are a bit different than what you would do as a human against a machine. First of all, because machines to machines communicate all the time. Second of all, because it's not about clicking here or there, it's more about streaming information back and forth all the time. So pitfalls are very different than the typical pitfalls between humans and machines. Pitfalls can be, well, the typical API attack, let's put it this way, starts with tinkering around with your API endpoints. You might have an API endpoint which expects a GET request, an array, and a date, whatever. And so a malicious individual might start playing with that array and that date fields and start sending you integers or whatever else in order to see how your API reacts. Let's take a step back. When you develop API endpoints, you do what's called input sanitization, or at least you should do, your developers should do. However, developers are under extreme strain these days. We all love doing 17 releases a day, if not 25, right? So little is the time developers have left to do input sanitization. And when you're dealing with tens and tens of complex API endpoints, some doors are left open, okay? Or undocumented simply, right? That's exactly what malicious people are after. They're after a way to send your API gateway into a buffer overflow, or to make so that by playing with fields, you'll send out your whole customer database, including PII data, right? And that's where API security steps in. API security is yet another family of solutions aiming to protect you from this kind of attacks. They do this in many different ways, and there surely are a lot of acronyms to be spent here, like AI, right? And ML maybe, and baseline and anomalies, of course. So in a nutshell, what these solutions do is they start receiving your data, they mirror it, right? They see it coming through and they pass it on. They create a baseline of how an endpoint should be interacted with. And as soon as things start diverging from the baseline, they, as a least, inform you in real time about that. In fact, tools like these are actively used by our clients to even debug and do the input sanitization we were talking about before. However, these solutions can also be connected with other solutions which you might have to protect you and to basically start banning IPs, users, whatever, so that you can have a whole automated flow for protection when it comes to API data. I hope I kept it easy, Nesh, didn't I?
Yeah, I think so. And I'll throw another acronym in there just because why not? This is going to be the most acronym-filled episode ever. On top of that, when you're looking at that API security piece, in order to test those API endpoints, now seeing the what DAST tools, so dynamic automatic security testing tools. And you can think of this as pen tester in a box, if you like, something you call as part of your CI/CD process. So you're going to release a new API endpoint, and as part of that, you automatically run a DAST scan, and that tries 100,000 permutations of exactly the sorts of things you're talking about, where you say, what happens if I throw an integer instead of a number, or what happens if I try and do a buffer overload, all these things. So the kind of, I just think it is auto pen testing, really. That's becoming pretty common now. And we're seeing a lot of tools for that on the market. What's interesting about API security particularly is that, if you lock down your entire estate and it's like Fort Knox, you still have to provide an API in to do business with most other people, either from a website point of view or from a B2B point of view. And it becomes the one way into your estate. And quite often that one way into your estate can become not just a pinprick hole, but, a gaping hole into your infrastructure. And it's interesting because we've been talking about it for, again, a good few years because we're head of the innovation curve and people weren't interested. Now we see they are interested. And what's more, that everyone's familiar with the OWASP top 10 for security on websites. Well, at the start of this journey a few years ago, there wasn't one for APIs. And now we have OWASP top 10 for API protection. So we can see that the market is maturing there. We can see that everybody knows it has its own OWASP category now. So definitely, if you haven't been worrying about that up until this point, you need to worry about it. And what's interesting is it's not covered by your traditional technologies. So we talked about CNAPP, Zero Trust, and SASE. None of any tool is covering that will cover your API. And typically your default web application firewall providers will do some effort to cover APIs, but actually they don't cover you for the zero-day attacks on APIs, because a lot of the time what you're doing with the API is getting it to respond with what we would call in HTTP terms a 200 OK. So you've sent something to the API and that's allowed, and that's why the data's come back. And we've seen this in the news. I won't list a specific example, but if you look at API leak from a company, you'll see it's full of top level stories from companies like Uber and Google even. So you just have to ask yourself, if Uber and Google can't get this right, is anybody, basically. So it's I think we're just at the start of the journey with API security. It's a super cool, interesting space. I happen to know the number one OWASP flaw was, and I've been told always will be, the BOLA, which is the broken object level authorization, and that's where you put in the URL path, HTTPS my bank / get balance, or my account number get balance, and then rather than putting my account number, I put your account number in, and I get the balance back of your account. And if the API allows that, that's a BOLA attack. And there you go, little fact for you of the day.
Neat. So, Nesh, let me see if I got you right. I can get myself an API security solution, and then my code is safe, including open source code, right?
Again, in the land of fairies and sugar plum fairies, maybe. No, we're still open, unfortunately. Interesting that most companies in a survey didn't actually know if they were doing something about open source vulnerabilities. So more than 50% said they didn't actually know. And this is a huge one, that people are packaging and baking vulnerabilities in open source code. And just for those who don't know, nobody is writing their own code in order to build an application these days. You just get lots of different bits of open source that are available, and then you knit and you weave them together and you knit them together in ways that are useful to you in order to make an application. And then if a vulnerability is found in those, then your application is vulnerable. I think they're probably the most well remembered in recent history would be the Log4j or Log4Shell attack, which was sometime Christmas a previous year, which kind of ruined loads of tech people's Christmas, as they had to run around finding out where they were exposed for Log4j. And these kind of things happen over time. They had Heartbleed, Poodle, and XYZ, other friendly names for these various sort of vulnerabilities that have come over time. And common misconception on these is that if you take the latest version of software from a vendor, that is a clean version. And this is absolutely not the case. The latest version of Node or the latest version of Nginx or something, a package like that from the internet, is typically riddled with critical errors and hundreds of high impact vulnerabilities. Don't know what your thoughts are on that.
Wait, are you telling me that my supply chain code isn't safe? Wow, that's groundbreaking news. Nesh, I didn't think about it. Okay, worth paying attention to. And so I think we could keep exploring more and more and more attack surfaces, but the ones we already mentioned bring us to the famous analysis paralysis situation, which you, Nesh, introduced in the beginning. Care to explain a bit?
Yeah, for sure. Analysis paralysis, it kind of like does what it says on the tin, but knowing that there is so many attack vectors and knowing that there are so many pieces of software that cover those attack vectors, and knowing that it's going to take you a long time to do a successful POC or find out if these guys actually work or not, leaves you to the point where you can't or don't buy anything. I mean, we see it every day. We're in conversation with these customers, and it's what makes us that's how you end up talking to a in quotes security expert or something like that, because you're like, hey guys, we want automatic pen testing. What do we do about that? Or we know we need to do something about cloud security. What do we do about that? And maybe sure, ChatGPT will give you some sort of half-baked answer, but I know for a fact that ChatGPT doesn't work in the wild and see what these tools look like. But it's a big landscape.
Yes, it is. And I think the biggest problem, as you mentioned in the beginning, has everything to do with too much data. Assuming you out there listened to our advice and got yourself a CNAPP solution, a SASE solution, an API security solution, an open source code solution. Yeah, and then you are also streaming logs of your routers, of your firewalls, and of your countless other acronyms in the industry. What do you do with that?
This would be, I say, probably the most difficult and tricky aspect for any company to solve, and especially if you're a small to medium one, and it's your SIEM and your SOC. So more acronyms to throw at you, but your system information event management, that's your SIEM, and then your security operations center, and that's your SOC. And to be honest, in the wide world, building your own SIEM and trying to build your own SOC just seems like insanity today, given that there are so many places you can get information from for your SIEM. And what we've seen in the recent years is what used to be quite simple to collect in terms of log data, which would be maybe your routers, maybe your firewalls, maybe some stuff about your estate and a few bits and bobs. It's exploded now. So now you need to get your logs from Office 365. You need to get it from your single sign-on, your Okta. You need to pull logs about your Google Cloud Drive, everything to do with your cloud estate, plus all the other pieces of software that interact with you. You've suddenly got an overwhelming amount of data coming at you. And yeah, what do you think about that, Francesco? How could we solve that?
Well, I think you got me paranoid enough and wanting to stream all these data. However, all these data is a nightmare to be scrutinized, especially if in real time, especially if 24/7 by 365. And that's where so-called SOC as a service companies, come in. Generally, security teams are understaffed. It's a strange equation. I see it everywhere I go. There's always less security people than you would need. And because if you followed our advice, you got yourself solutions to cover all of these aspects and countless more we couldn't cover today. There's simply too much noise for you to look at, right? SOC as a service solutions are indeed the ones to help you on this, because you don't have a single dashboard anymore, because you don't have a single repository anymore where to scrutinize all these data coming at you real time, all the time, in gigabytes, if not terabytes, if not petabytes worth of them. Yeah, that's what these companies are for. You choose and vet what's most appropriate for your scenario. You write down a so-called run book with said company, where basically you define all processes and escalations and procedures and what to do if. It's a lot of what if scenarios, right? So that they know exactly how to operate in all instances. And that's it. They become your eyes and ears out there in the wild. You can sleep tight at night, or you can almost sleep tight at night, knowing someone else's eyes will be looking at these petabytes worth of incoming data all the time. And if there's anything wrong with any of these data, then there will be procedures for these people to escalate and do the needful, right? Whatever. Has a laptop being infected with malware? Well, cool. They'll escalate to the infected laptop owner to flash his or her laptop. Has a router gone bananas? Well, if it's a physical router, they'll send another router and someone to install it, etc., etc., etc. This is, in my opinion, a way for you to make better use of your money and of your security people, right? Keep them where they're needed the most. And at the same time, to really scrounge through all these data, which you, if you followed our advice, now have.
Yeah, and I think, the piece of advice sort of at the beginning of this is the biggest bang for your buck was to get a CNAPP, because it encompasses so many things. The SOC as a service, or SIEM as a service, whatever you want to call this sort of emerging industry, I would say, unfortunately, it's not for everyone because it's expensive, and you have to be of a security mindset or care enough about that, or be large enough about that to look at that. And I'd say probably that happens at around the probably between 50 and 100, but typically more than 100 employees before you're really looking at something like this. But it might not be the biggest bang for the buck in terms of what you get, from 0 to 80, let's say, if you get with a CNAPP. The bit that you get with a SOC as a service is that peaceful night's sleep as the CISO. And it's actually, even if it is expensive, I think it's almost invaluable, because that you will probably miss the alert. And there's always a way for someone to come in. There's always a 0 day, there's always an exploit, there's always something. You get to the point with these SOC as a service type companies where actually, if you push enough of the data and you've really been honest about all the different places what you consume services, the odds are you will find that needle in a haystack, or rather, not you will, but your SOC as a service provider will find that needle in a haystack. And it might not be the biggest bang for the buck, but it's definitely the most important bang you might catch. It's and again, that's a huge growth thing. It wasn't really something that people were interested in a few years ago, and I see crazy explosion of using machine learning and things like that to help build out that service. And I think on that note, we're probably at a wrap up and out of time. We covered a heck of a lot of topics, and if nothing else, hopefully now you understand a whole bunch of acronyms that you hadn't heard before. If you like the content and you'd like us to produce some more, please reach out to us, subscribe, like, and generally show us a bit of your support, and we can easily create more of this. This stream actually ends now, but we'll jump into asking any questions you may have asked in the next 5 minutes. So please, if you did ask a question, wait around for that. Been great hosting you. That's all for now. Hey, great. I had a small problem turning my camera on at the end of that. I do work in tech, I absolutely promise. So thanks for joining us on that webinar. Again, we did pack in a lot of information there. And we have got a bunch of questions that we're going to come to. If you didn't ask your question yet, please do put it in a chat, and hopefully we can get around to it. I'll read them out. As the head of a security for a mid-sized e-commerce business, I'm confused by the range of solutions you discussed today. It seems a bit overwhelming. Could you clarify what would be the best method to assess my current cloud readiness? What should I do first? ? Okay, so if you're already a cloud native user, so you're in AWS or GCP or Azure, and you're not sure what your first step to take is, you definitely ought to look at a cloud security posture management solution. So we talked about CNAPPs in the webinar, but really cloud security posture management is the bit that's just going to scan your estate, and it's going to look and see, have you got open S3 buckets? Did you set your login password needs to the right level? So character, numbers, letters. Are you using multi-factor authentication? When was the last time you recycled those passwords? Et cetera, et cetera. All those kind of basic configuration mistakes that you might have made if you're new to the security journey. So that'd be the number one tip. Number of tools on the market for that. But yeah, cloud security posture management would be step one. Just to find those easy, low-hanging fruits. And to be honest, if you didn't look at something like that already, you're very likely to. That's how you're going to find your open S3 buckets. That's how you're going to find your access key that hasn't been rotated for 3 years or something like that. So, and if you get to that point and you realize you need a bit more, the very natural next step is, if you want to see more information about vulnerabilities that you're currently running on your containers or lateral movement that's happening inside your cloud account, the next step would be to look at a CNAPP. So basic first step, cloud security posture management, and then immediately after that, have a look at a cloud native application protection platform. If you've got any money whatsoever, just start with a CNAPP and just take the plunge in there, because the benefit you'll get from that will be massive in comparison to just a posture tool. Next question: how can we ensure that security measures won't hinder the performance of our applications? Have you got any real world scenarios from your customers where this was successfully achieved? So yeah, there are 2 ways, or rather there's, let's say, 3 ways of looking at security technologies. You're either out of band, which means that you're not running an agent on the actual machine itself, but you're able to scrape the data in another way, and that way you're not interfering. And then there's inline, which would be, as you can imagine, means in line with the security stack. So that could be either a security tool that's running, that you have to go through a proxy, and or an agent that's actually running on a machine and therefore taking up resources. So that's the best kind is out of band. Worst kind is, or most heavy on your infrastructure, is inbound. And then there's cloud platforms, SaaS platforms, whereby you do have something that's inbound a little bit, or a light agent, but actually it's just sending metadata somewhere else for a cloud to process that. And I do have examples of real life situations. So if we're looking at cloud security, particularly, there's a very large argument happening within the cloud workload protection and the cloud native application protection platform space as to whether the agent is king or whether agentless is king. And for my money, the agent is king, but actually if you want absolutely no impact whatsoever on your environment, agentless is the way to go. And how that works is it can take a copy of everything that's running inside, let's say, AWS. So it takes a copy of your VM, then opens that snapshot and analyzes that snapshot for vulnerabilities or file integrity, things like that. So that's happening completely out of band. So that's a kind of agentless approach. Looking the difference there, or the problem would be, you don't get real runtime live activity, what's happening. So if you an agent-based model, then you're looking at putting a small agent on there, and you can see live DNS requests, live running processes, every single exe that's actually running on a host, all the DNS requests, and just everything is happening runtime with that, and all the packages installed. There's only a short delay, talking a few hours plus with doing the agentless version, but you just get more rich data using an agent. So if you don't want to hinder your applications whatsoever, look at agentless and look at out of bound. And that could not only mean in the cloud workload, but if you're talking about API security, a lot of API security tools are now available out of band, which means that you're scanning the payload data that's running through the API. So something is consuming those text files or those JSON files out of band, and then feeding back into the system what's happening. And more and more and more, AWS had an entire region go down literally yesterday, and it's the biggest cloud provider in the world. Cloud platforms go down, technologies go down. If you're highly, highly sensitive to that, always look for out of bound. And that way, even if the platform that's providing your API security falls down, then you're still up. It hasn't affected your uptime. Hopefully that answers the question. The next one was, how does autonomous pen testing differ from traditional pen testing methods? can you discuss the potential for false positives with autonomous pen testing and how they are handled? Yeah, so actually, the pen testing tools, which are the DAST tools, or so the automatic ones are DAST, which is dynamic application security testing. I think I said dynamic automatic in the webinar, which was just a spoken typo, whatever that is in real words. A DAST tool, actually, pen testers are just using these. So if you pay a pen tester to come into a company, he literally has access to a bunch of tools, bunch of security pen testing tools, is running those DAST tools and those inside your environment, and then just writing you a nice report. So what's the difference? Absolutely nothing, except maybe you don't know how to run the tools yourself and you need to pay for someone to come in and do that. My gut feeling is that the era of pen testers is coming to an end. There are certain companies that will always survive that, and they'll always be there. But for the average company, I think pen testing is just going to be a dead thing within a few years as DAST tools become more common. A question around false positives. A manual pen tester would also provide you with the false positives. There's not really much you can do to avoid a false positive. That's just that's the nature of everybody's infrastructure looking slightly different and trying to apply one set of rules across that. But that's the job of the person who owns the infrastructure, to analyze all the results that come back and just have a look at those false positives. I mean, the possibility of them, whether doing it autonomously or whether you pay someone as a human to do that, is exactly the same. So no real difference there. But moral of the story, don't pay for a pen tester. You can just use a DAST tool. What steps does your organization take to stay ahead of new open source code vulnerabilities? Is there a specific process or methodology you follow to continuously update your knowledge base and tooling? So if you don't know, there is a very, very large online database which is managed, called the CVE, which stands for Common Vulnerabilities and Exposures. What's the difference between a vulnerability and exposure? A vulnerability is a spotted problem within an application, and an exposure is somebody is actually exploiting that. So there's a difference between a vulnerability and something that's being exploited. But the CVE database is managed by the MITRE company, and MITRE is also providing the attack frameworks that everybody talks about. So all the different kinds of attacks that you can have on an organization, the definitions of those come from MITRE, and the whole thing is actually financed by the US government as a way to help all of the security industry have a baseline. So the classic way that things come into or CVE, anybody can announce a CVE. So if you find a vulnerability within an application or something, you can publish a CVE, and then multiple people who publish the same thing at the same time, will be amalgamated into a single CVE. So say, for example, things that people would have heard of over the years, Heartbleed, Poodle, Log4j more recently, or Log4Shell, things like that. So these are common known vulnerabilities, and they get put in the database. And then all the security companies will subscribe to not only that, but other databases to pull in that sort of information. So when it comes to open source vulnerabilities, they're all identified by CVE numbers, which, there's a web page that maintains what is in that CVE, what this vulnerability is, how to fix the vulnerability if there is a fix, and the score. So CVSS score, which basically means how deep are you in the poop if you have this, and then if you're analyzing your open source code, you'll see these, you have all these CVEs with a rating, and it'll tell you which one you need to attack first. So nobody is actually, individually maintaining their knowledge about what's going on with vulnerabilities. This is looked after by the likes of the American taxpayer, whose government has made that for us. So isn't that nice? Something good from the American taxpayer. And this could be our last question. The SASE and zero trust are gaining prominence in the field of cybersecurity. How can we as an organization decide what approach is suitable for our specific needs? Are there scenarios where we could implement both simultaneously? So SASE and zero trust has a lot of overlap. I think it's the difference really is that SASE is a way of providing network infrastructure where you have a bunch of modern features, such as hosted in the cloud, all your infrastructure backed up, everything's driven by software, event-driven rules, available everywhere, etc., as opposed to the previous world of you having to manage your own routers, firewalls, VPN connections, etc. So the SASE, or the Secure Access Service Edge, is a software edge, which means you can access your data from lots of different places, be it your office, hotel, whatever, all around the world, and helps to put a boundary around all those other tools that you use that you don't own the boundary for, like Dropbox, like Office 365, like Salesforce, like insert SaaS tool. So that's really, SASE is the kind of the network that underpins that. Zero trust is not really a tool. Zero trust is a framework for how you allow people to access. Now, you can have zero trust without a SASE, and you can have a SASE without zero trust, but they work very well together, because the sort of foundation of zero trust is that you authenticate every time. So you check every single time that that identity has the right privilege to access this application. You log everything, and there's a system whereby a software system that's saying a certain user or certain groups has access to these certain applications, and then can be at certain times, and etc. If you can do zero trust without a SASE, but SASEs are built to make zero trust infinitely easier. So, it makes perfect sense to do both at the same time. And you'll find that, the SASE providers, almost without exception, now provide some kind of VPN client, although VPN client is kind of not the correct word. It's kind of a zero trust client, or insert a new acronym there. But essentially, they come with a piece of software that can be run on a local machine, or on an iPhone, or on an Android, that enables you to access your SASE cloud, as it were. So then once you put everything behind your SASE, so your SASE becomes like your circle of things that you trust, and then your zero trust client is then works a lot better with the SASE. So that's hopefully answers the question. I don't think we have any more. Thanks for joining. Pleasure having you. We are GlobalDots. We are cloud innovation hunters. We go digging around, finding super cool technology so that you don't have to. I'm happy to talk about this stuff all day long. Please reach out to us if you're interested in any of these topics, API security or cloud workload protection. Usually you have to pay like $1,000 an hour to speak to an expert about that, but we do that bit for free because we're the nice guys and girls. And yes, hope to see you all out there in Cyberland somewhere. Ciao for now.